In this question, it is given that let z be a complex number such that mod of this is equal to 2 and z is not equal to minus I, then z lies on the circle of radius 2 and center. You have to find the correct choice. Agreed. This question can be done by supposing z equal to x plus yi and simplifying this equation and get a Cartesian equation in x and y, and from that equation you can easily find the center. But the proper and short way of doing this question is doing this question with the help of complex numbers only, that is without converting this equation into Cartesian form. To understand the solution, first let me tell you the concept which I am going to tell you. Mod of z minus z1 upon z minus z2 is equal to k, where k not equal to 1. Remember that this equation always represent a circle, and for that circle how to find the center and radius I'm going to tell you. But again I will say, for complete theory of this which I am going to tell you, you will have to see my video lecture of complex numbers made for JEE level. As we know that this can be written as z minus z1 upon mod of z minus z2 equal to k, where z1 and z2 are fixed complex number, z is variable complex number. Clearly, this implies the distance between z and z1. This gives the distance between z and z2. That is, I mean to say, suppose this is the point A and this is the point B, and this has complex number z1 and this has complex number z2, and P is a variable point whose complex number is z. PA upon PB, according to this, PA upon PB is equal to constant k, where k is not equal to 1. Remember this thing, that if k is not equal to 1, then locus of P will be surely a circle, and that circle is called Apollonius circle. That is, the circle will be of this form, for which out of A and B, one point will be outside the circle, other point will be surely inside the circle. Note that the circle will be on this side if this upon this is more than 1, and if this upon this is less than 1, circle will be of this type. And if k is equal to 1, in that case locus of P will be a line which is perpendicular bisector of AB. That is, I mean to say, if A is here, B is here, if PA upon PB, that is equal to 1, means PA equal to PB, then locus of P will be a straight line which is perpendicular bisector of AB. And using these concepts, I'm going to do this question. This is very important concept, very useful concept. The complete theory of this, that why it is circle, etc., that is complete geometrical interpretation of this concept, you will have to see my video lecture of chapter of complex numbers made for JEE level. Here this equation means mod of z minus 2i upon z minus I is equal to 2. And according to the concept I just now told, first I will draw a line joining minus I and 2i, and z is a variable point and the name of that point is P, and suppose this is A and this is B, and according to this condition means PA upon PB is 2, that is PA upon PB is not equal to 1, that is the ratio is constant. It means locus of P will be a circle called Apollonius circle, and for that circle A will be outside, B will be inside, because this is greater than 1. That is, circle will be of this type. But note that I'm not saying that the center of the circle will be at. To find the center of the circle, I will find the complex number of this, I will find complex number of this, and the midpoint of that will give you the fx of center of circle. For this point, because this condition is true for every point on circle, therefore for this point also this condition must be true. That is, for this point, this length upon this length should be 2, and say this point has complex number alpha, then alpha will be equal to 2 into minus I plus 1 into 2I upon 2 plus 1, that is 0. Means this point is actually here. And to find the fx of this point, that is a complex number of this point, because this point is dividing AB externally in the ratio 2:1. Say this point has complex number beta, that is suppose the fx of this point is beta. To find the fx of the point beta, we'll be using the concept that this point divides AB externally in the ratio 2:1. That is, with the help of this formula, just write minus here and minus here, you'll get the value of beta, that is 2 into minus I minus 1 into 2I upon 2 minus 1, that is minus 4I. And because we had concluded that alpha is 0, beta is minus 4I, hence the center of the circle will be at minus 2I. That is, the center becomes 0, minus 2. Hence I can say fourth choice is the correct choice.